So last class what we discuss shift registers, right? Someone writing, okay, don't write down board, please. Shift registers, right? So what we discuss, serial in, serial out, serial in, parallel out, we discuss. Okay, so we need to be discussed. So we need to discuss parallel in, parallel out. 4-bit parallel in, parallel out. Keep a heading 4-bit parallel in, parallel out, shift register. So how many registers, how many flops are required? 4 flops, right? Yes or no? 4 flops are required. 4 flops are required. So D0, Q0, Q0 bar, CP, D1, Q1, Q1 bar, D2, Q2, Q2 bar, D3, Q3, Q3 bar. So now, so here it is parallel in, parallel out. Getting? The data will comes parallelly input. Comes like this. And output will goes like this. Before that, we will have clock, common clock will be there. This is CLK. So this is parallel out. Okay. So this is the output.
So what is the meaning of CK?
This is the input. CLK clock. Clock, different names they will call. Okay, CLK they will says. Okay, they will says. Okay, CK they will says. Shortcut they will call like that. Okay, so just you can write clock instead of this. You can write clock. It's also clock. Okay. So now here parallel in, parallel out, what happens? If I will give one clock pulse, okay. For example, I want to be shift 1011. I need to shift 1011. So if I will give that here 1011. So if I will give one clock pulse, so then this Q0 becomes 1. So this Q1 becomes 0. This Q2 becomes 1, and this Q3 becomes 1. So it will get to output directly. Getting? So here more clock pulses are not required. Even though 100 bits are there, only one clock pulse is enough. Parallel in, parallel out, how many bits are there? Okay, so how the number of bits are anything. Okay, so the clock pulses are only one clock pulse is required. So whatever input or whatever input parallel inputs are there, those all will be go to the output. Clear? So parallel in, parallel out, how many clock pulses are required? 1. They want to trap you. They will say that okay, 4 parallel bit. Okay, 4. Hello, can you please mute mic? So they want to trap you. They will ask question like okay, 4 bit parallel input, parallel output. Okay, shift register will take 1 clock pulse. So then 100 bit parallel in, parallel out shift register, how many clock pulses it will take? They will ask like that. So then 4 1 means okay, 100 how much? So you will calculate 1 by 4 into 100. So you will calculate 25 clock pulses. Gone. Sir, no. So you need to apply the logic, not the mathematics. Clear? So here you need to apply the logic. Parallel in, parallel out, even 100, 200, 300. So will require only 1 clock. 1 clock pulse is required. Clear? So this is the parallel in, parallel out. Any questions here? Any questions here? So now next, sorry, parallel in, serial out. 4 bit parallel in, serial out, shift register. 4 bit parallel in, serial out, shift register. So how many flops required? 4 flops are required. This is 0, this is 1. 0, 1. 0, 1. 0, 1. This is B0, Q0, Q0 bar, P1, Q1, Q1 bar, D2, Q2, Q2 bar, A3, Q3, Q3 bar. Now, the output, this one, and this one will be 0. This one, whatever the input you want to do. This one output will be critical. This will be critical. This. This is the serial out. Okay, serial out. Okay, this is the clock. Clear? This is the clock. So now, if you observe here, so what I am using, one more thing, selection line also will be there. This is the selection line. S. S. S equal to 0. S equal to 0. When S equal to 0, it will choose 0. When S equal to 1, it will take 1. Get it? S equal to 1, it will take 1. So when S equal to 0, data loading. Data loading. S equal to 1, data shifting. Data shifting. S equal to 1 is data shifting. S equal to 0, data loading. For example, I want to be shift data is 0, 0, 1, 0. I want to shift this data. Okay. I want to shift 0, 0, 1, 0 data. So now, so I will give 0 here, 0 here, 1 here, 0 here. Okay. So now my S equal to 0. First, what I need to do? S is input now. Yeah. S is a selection line of a mux. This is a mux, 2:1 mux. Today, S is a common selection line for these are all the muxes. Clear? Muxes. So we'll repeat, you will understand that one. So CLK Q0, Q1, Q2, Q3. So now S equal to 0. S equal to 0. When first clock pulse, all the 0 only will be passed to the output, right? 0 only passed to the output. So then all the Q0, Q1, Q2, Q3 becomes 0, 0, 1, 0. 0, 0, 1, 0. This 0 is a first output. This 0 is a first output. After that, what happens? S equal to 1. S equal to 1. Next clock pulse is 2. When second clock pulse comes, now S equal to not a 0, not this one. It is 1, this one. Okay. So this one. So what is the input here? 0. This 0 will be low to here Q0. Getting? So means Q0 becomes 0. This 0 will be shifted to here. This 0 will be shifted to here. This will be shifted to here. This is the second output. So now, so S equal to 1, third clock pulses. Okay, again, here we are giving 0 only, right? 0 only. So then this is 0. This will be shifted to here. This will shifted to here. This will shifted to here. This is the third output. Third output. Okay. So next again this one is 1. So this is the fourth clock pulse. Okay. So this is 0. So this will be shifted to here. This will be shifted to here. This will be shifted to here. Yes or no?
Yes, sir.
So this is a
Fourth answer.
sorry.
No, sir, it is correct.
Oh, 0, 0. This one is 1. 0, 0, 1, 0. Yeah.
First,
Yeah. Fourth output. Fourth output. Getting? So now you need to check from here to here. This is MSB. MSB. This is a LSB. Getting? Getting? LSB to MSB you need to check 0, 0, 1, 0. Clear? So how many clock pulses are required for this? Parallel in serial out. 4 clock pulses are required. Okay, 4 bit parallel in serial out. How many clock pulses are required? 4 clock pulses are required. 4 bit, 4 clock pulses. N bit, N clock pulses. 100 bits, 100 clock pulses. So 1000 bits, 1000 clock pulses. Clear? So now we'll see the summary of these all things. Okay. What is the summary? What is the summary? Serial in, serial out. What is the clock pulses required? Serial in, serial out. What is the clock pulses required? 2n minus
2n minus 1.
2n minus 1. Serial in, parallel out.
N.
N bit, N bit, N clock pulses.
N clock pulses.
Serially, sorry, paralleling, serial out,
Yeah.
paralleling, serial out,
N bit, N clock pulses.
N bit, N clock pulses. So paralleling, parallel out,
Single clock pulse.
only one clock pulse. Clock pulse is required. Clear? This is the summary. Shift registers. You want you can write. Otherwise, there's no chance. Clear? Any questions? Any doubts here?
Sir, can you explain how to take selection line?
Sorry.
Selection line.
Selection
How
line
to
is
choose
0.
selections?
Selection line is 0. What it will take? This one is 0, right? Whatever data is there, the data will be loaded. When clock is 1, so then clock is 1, the data will be loaded. Getting? This is the selection line 0 input. 0 input.
Always we take like this 0, 1, 1, 1.
No, this data can be changed, right? So this is, for example, I am saying 1 1 0 1 you want to take. This is 1 0 1 1 0 1. Anything you can give. Getting? After giving, to get the output, you need to wait for 4 clock pulses. Getting? This is example I am giving. This is as an example. I already clearly told from last class. This is example. Clear? You want to change, you can change here. You want to change, you can change here. Data every time. Getting? But this one will be always 0. This one will be always 0. You are not giving any signal right after that. So you will give here 0 0. So for suppose consider 1 1 0 1 you are giving. So 1 1 0 1 only will get output after 4 clock pulses. What is the thing? Understand? Yes.
Sir.
Still you have question? Hello?
Sir, can you shift to the number 1101?
1101. What happened? 1101. So with first s equal to 0. When s equal to 0, what happens? It will take only this 0 case. This data will be shifted to this D0. When clock is present, so then all this data will be presented here. Getting? So what it will get? 1101 will get. 1101 will get. I will show you here. As CLK clock. So this is Q0, Q1, Q2, Q3. So now S equal to 0. When clock pulse, first clock pulse. So then whatever the data we are giving 1101. If I am giving data 1100, then 1100 only it will take. You need to be give here. So this is this is A, B, C, D. A, B, C, D, it will change every time. Getting? A, B, C, D will change every time. So now I'm giving, for example, 1101 I'm giving A, B, C, D. A equal to 1, B equal to 1, C equal to 0, D equal to 1. Clear? When I am giving this one, what happens? So then Q0, Q1, Q2, Q3. So when first clock pulse will comes, so then it will be take this as a input, right? Yes or no? When S
Yes,
equal
sir.
to 0, S equal to 0, so data is loading. Data is
Yes.
loading. Means this one it will take. 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 Clear? So then what happens? So 1101 will get here. 1101. Clear? So this one is already serial out. This is the first output. First output. Clear?
Clear.
So next, this one is 1.
1.
Now I'm maintaining this one serial. This one is 1. Means we are disconnecting this A, B, C, D. We are disconnecting. We are only connecting this path, then this path. So then this path, then this path. Now I am shifting the data. Getting? So I am not connecting with A, B, C, D. Getting? So if you want, I will go with the color. Then you will understand. See, now data will shift like this. Getting? Now I need to maintain S equal to 1 until my data will be comes out. Clear? So now S equal to 1. So my clock will second clock pulse. So now what happens? So I'm giving here 0. Default I'm giving 0. So then, so this one is becomes 0. So then this one shifted to here 1. This one shifted to here 1. This one shifted to here 0. So this is the second output. So next my SE is 1. ABCDs are disconnected. So now this is the third clock pulse. So again this one is 0. This one shifted to here 0. This one shifted to 1. This one shifted to 1. This is a third output. So next my S equal to 1. Fourth clock pulse. This is 0. This one shifted to here. This one shifted to here. This one shifted to here. This is a fourth output. So now you need to see bottom to upper. Bottom to upper.
You change the
1101 output we are getting. Clear? This is the thing. This is the only, right? We discuss. Any questions, any doubts still? Very simple.
Yes, sir. Clear.
So now, so this one is clear, right? So keep a heading, finite state machines. Finite state machines. Finite state machines. This is I. Is not properly written. Finite state machines. Okay. Finite state machines. What is finite state machines? Where we will use. So we in the last class we discussed about combinational circuits as well as we discussed sequential circuits. So then counters we discussed, shift registers we discussed, right? So combinational circuit, what it will do? So based on the present inputs, okay, based on the inputs, it will generate the output. Yes or no? So this, if this is a combinational circuit, combo circuit, so based on the present input, it will generate the output. For example, so present inputs are 1, 1. For suppose this is a 1 AND gate. Sorry, this is a 1. For suppose consider this is a 1 half adder. Output will be sum is 0, carry will be 1. Always 1, 1. Output will be always same. This is the output only you will get in the combinational circuit. But when come to the sequential circuit, it will have one memory element, right? Memory. If I am giving 1, 1, for suppose this is a JK flip flop. JK flip flop 1, 1 I am giving. Memory is 0, so then output becomes 1. Memory is 1, output becomes output becomes 0. Mean what happening here? So the same set of inputs, output will be changed in the sequential circuit, but same set of input, okay, output will be same in the combinational circuits. Okay, so to achieve this sequential logic, we will use these finite state machines. Okay, so to achieve this sequential logic, we will use the finite state machines. Same set of input, okay, outputs will be changed, so that we need to be find out by using the finite states. Okay, we'll use this finite state machines. Clear? Simply, if I want to say one logic you need to implement, there are number of conditions. For example, if I want to say, okay, traffic lights, what happened? Every 5 minutes it will change, right? Yes or no? Yes. So every 5 minutes it is changing. How we are making that? How we need to implement that one in the circuit? How we need to tell that okay circuit every 5 minutes it need to be changed. So how many flops are required for that? Okay. So these things is important. These things is important. So that logic, okay, whatever thought is there, the thought process I need to implement. I need to implement as a circuit. For suppose example, if one more example, if I want to say, so you in your home you have a tank, water tank. What? If water tank is full, so then what happened? Motor should be off. Okay. So suppose this is the water tank, complete water tank. This is the full indication. This is the empty indication. Empty indication. Okay. So if full indication is there, okay, it will reach to full indication. So then motor should be off. When it is reached to empty indication, okay, empty. So then motor should be on. So then this I need to implement in the circuit format. How I can implement that? What are the states required? What are the logic required? Yes or no? I need to check those all the cases, right? So those we can derive from the finite state machines. Where the data need to store, okay? So data need to process. Then we need to get the final output. Clear? So these finite state machines are two types. What are those? Melee or Melee machines and Moore mission. There are two types of finite state machines will be there. Melee mission and Moore mission. Clear? So now we'll see the difference between this Melee mission and Moore mission. Melee mission and Moore mission.
L-O-L-E.
M-O-O-R-E.
R-E.
R-E. More. Okay, Melee mission and Moore mission. So now in this, if you observe what is the main different means, this Melee mission output depends on present state and input. Present state and input. The output of a Melee mission depends on present state as well as its input. Okay. So Moore mission output depends only on present state. What of the state mission? What is the state is there? Only that state it will be present. So now if the circuit, if you are checking, okay, what is the circuit of this one means next state combo circuit. Okay, after that we'll have state register. After this we'll have output combo circuit. Then this one is output. So this one will give clock here. This one will goes as the input again to the present state, as well as input will be there. This input directly connected to output combinational circuit. Clear? Output combinational circuit. This is the Melee circuit. Okay, it will be like this. Means input some combinational circuit, that may be AND gate, OR gate, NAND gate, anything mixed. Okay, it will be there. And output also some combinational circuit will be there. In the middle we have a resistors. Resistor means flops. Clear? So this is a Melee circuit. So if you go to the Moore circuit, so next state combinational circuit. Then state register. Output combinational circuit. So then this is the output. This is input. This will be goes as like this. But input directly not connected to output. Okay. So input directly will not connected to output in the more. Here input will be directly connected to the output. That's the reason output depends on the present state. This state as well as input. Getting? But here output only depends on the this present state. Whatever the state is there, so that state only it will be depends. Getting? Getting? Here two inputs are there for output combinational circuit. But here output combinational circuit only one input is there. That is present state. State of whatever the state of that register is there, that only will goes to the output. Clear? Clear? Any questions? Any doubts here?
सर इस 20 नीचे का लिखा
This one clock.
नहीं स्टेट और वही पे जो नीचे लिखा
State register.
रजिस्टर
Yeah. State register. Clear? So this is the circuit. Okay, if you see this circuit, you can directly says what is the problem, what is the problem, you can directly says. Okay. So here the main problem is input change, output directly will change. Okay, input change. Okay. So with respect to input, output will change. But the main problem here is input is suddenly changing, output also suddenly will change, will cause the glitches in the output. That is the disadvantage of Mealy. So input is changing, will cause immediately output change that result in the glitches in the Mealy circuits. No doubt. Second point, input changing will make output immediately change, cause the glitches in the output signal. Next here in the more. Okay, more. So what you need to write? Input is not connected to output combo logic here. Input is not connected to output combo logic. It will not create any glitches. Output will not have any glitches. Simply
is not connected to
output combo logic. That's why output will not have any glitches. Mealy mission is very fast because input changing, output is immediately changing, right? That's why output will not have any glitches. So Mealy mission is very fast because input is changing, output immediately will change. Mealy mission is fast, but More mission is slow. More mission will be slow. This is one more different. And next difference is so for n bit n states are required. States are required. Here n bit n plus 1 states are required. Okay, n bit n plus 1 states are required. Clear? So some other differences also there. Output synchronously change based on the input changing. Here output will be synchronously change based on the state changing. State will be synchronously change based on the input changing. So those things you will know later. Okay. So main differences are these things. You need to know. Okay, this one is input directly connected. This one input will not be connected directly to the output. Clear? Any questions? Any doubts here? Any questions? Any doubts? N bit, n states, n bit, n plus 1 states. Now how we'll use the finite state missions, we'll see now. Okay, how we are implementing finite state missions. What is the use of Mealy mission? What is the use of Moore mission? We'll see now. Okay, so for suppose consider, so I have a data. This is the data. How 1 0 1 1 0 1 0 1 0 0 1 0 1. So like this, I have a data.
It's assumes data.
Assumed data. Assumed data. Anything will be there. I am assuming this one. Okay, example. Okay, this is the example. So now my requirement is I need to be okay. Detect 101 from the data. From the data, I need to be detect the 101 from the data. So where 101 is there? This one is 101, right?
Yes, sir.
So this is one output. If one time it is 101 comes, that is the one output. Next step,
Second,
this one is
101.
second output. So next step, where it is?
Yes.
Third. Yes or no?
Yes.
Next step, fourth.
5. Last.
This one is fifth.
5th.
This one is whatever 101 you are detected, that is without overlap. Without overlap.
Without over.
With overlap, if you see, this is without overlap. Overlap. So now if you see with overlap, data how it will be. Okay. So now with overlap, how it will be 101. This is a one output. This is second 101, right?
Yes, sir.
This is second output. But this one is again, this one is common, this one is common. Okay. So again 101 is there with overlap. This is the third output. Getting? So after this one is
4 now.
fourth. So again this one is common. This one is fifth. This one is sixth. So again this one is common. This one is
7.
seventh. This one is
8.
8. So without overlap we are getting 5. With overlap we are getting 8. So here we are simply okay 101 is there. So we are seeing and we are identifying. But how circuit will know that? This is 101. Okay. How this we need to implement in a circuit format. Getting? So to implement that circuit format, so we need 5 steps. We need 5 steps. What is those steps? First step is state diagram. State diagram. First step is state diagram. State diagram of any logic. Any logic, you need to be first to do state diagram. Second step is state table. State table. State table. This is the second step. Third step is state table in the binary format. State table in binary format. Binary. Fourth step is K-map. K-map. K-map for each and every output. Okay. K-map. Fifth step is circuit implementation. Circuit implementation. So these are the 5 steps. These are the 5 steps we need to follow in the Mealy as well as Moore missions. Mealy as well as Moore missions. See, any data will comes, I need to detect 101. Any data, user given anything, I need to detect and I need to say that okay, this is the 101 sequence detection. Okay. So how I can do in that Mealy with overlap, without overlap, we will see now. Clear? We will see now. Note down this. Completed. Note down these 5 points. These 5 points are very important. These 5 points in Mealy as well as Moore missions, it is common. These 5 points. State diagram, state table in binary, K-map, circuit implementation. Clear?
101, for example, 101.
101 sequence detection, how in the Millet-More will see.
For example, you are taking number.
No, any data they will give. So I need to be detect 101 from that. Okay, any data, user let give me any data. I need to be detect 101. How I will detect? Okay, what circuit I will implement? I will show you that. Okay.
Number. G sir.
Fifth
No, sir.
is circuit implementation. Now, keep a heading 101 sequence detection. 101 sequence detection using melee without overlap. Clear? Without overlap. So now 101 first sequence detection I need to do. So first what I need to do? State diagram I need to be implement, right? First step is state diagram I need to implement. To implement that state diagram, I need to check how many bits is there. 101, 3 bits. 101 is a 3 bits. 3 bits are there. So now 3 bits are there. So how many states will be there means in the Millet missions? 3 n bit and states. 3 bits, 3 states will be there. Yes or no? 3 states will be there. What are those 3 states? S0 state, S1 state, S2 state. Here, 3 states will be there. 3 states will be there. So now 101 I need to detect. For suppose consider when here when I am checking here 1 is coming. So next I am going to next steps to check whether 1 is coming or 0 is coming. 0 is coming. So then I am checking the next one. So then 101 3 is 3 101 is there. 3 whatever I required that sequence is there. So then I am making output is 1. 1 means first I am checking what is the input. This one is 1 or 0. I am checking. So after that, if it is 1, I am going to next step. If it is 0, what I need to do? That we'll discuss here. See now S0 there are 2 chances are there. Either it can get 1 or it can get 0. It can get 0. So now, so if 0 will comes, what I need to do? If 0 will comes, for suppose consider in this you are checking here, okay, 101 sequence, it is 0. What you are doing?
Search 1.
You are staying the same place and you are checking for 101 position again. Yes or no? The same way here also what you need to do. So here, so when 0 will comes, you need to stay in the same state. Same state, output will be 0. This is a input, this is output. This is output. Okay, this is a input, this is a output. Clear? If S equal to 1, S0 is 1. So then what happened? I need to move to the next stage because I need to detect 101. 1 is coming. So then I need to move to the next stage. So this is 1, output will be 0. When output becomes 1, 101 sequence completely I am detected. So then output becomes 1. Now here is 1, S is 1, output is 0. So now S is already detected 1. Yes or no? So S0 is already detected 1. Means here already we have 1. Yes or no? Why you are confusing? See, this is 1. Already we detected 1 from S0. So now S1 will have 2 conditions. What is that? S1 will have 2 conditions. What are those?
0 1.
1 is already there. Next we can get 0 or 1 is already there. Next we can get 1.
1.
Wow.
So now 0 will get where I need to go.
1.
1 will get where I need to go.
0.
1 0 will get, okay. So 0 will get, I need to go to the next state. Next step. Okay. So this I will go to the next state. So this is 0, output will be 0. Still my sequence is not completed. 1, 0 completed. Okay. So if 1 will get, where I need to go? 1 is not 1, 0. 1 is my sequence, but 1, 1 I am getting. Getting? So then I should not go to the next state. So then where I need to go? So then what you need to do? No. What you need to do? You need to compare this one bit with this one bit. This bit with this last bit. Both are same. Both are same. So then you need to stay same position. If both are not same, so then you need to come back to S0. Ready? So both are same. So this is 1. Output is 0. Output is 0. So now here at S2, so we have already 1 and 0 we have. Yes or no? 1 and 0 is there, then only we went to S2. After that, we'll get two conditions. What are those? 1 0 0 or 1 0 1. Non-overlapping in Melee. By blindly, we can go to the reset. If it is a 0, if it is a 1 also, you need to go to the reset. Output becomes 1. That's it. In the non-overlap condition, okay, even it is get 0 or even it is get 1, you will get to a 0 condition. How? Simple here. 1 0 1. You are checking 3 bits. If all 3s are 1, then output is 1. After that, what you are doing? You are again freshly checking. Yes or no? You are not overlapping. Okay, you are not overlapping. So freshly we are checking. The same thing here we are doing. After the sequence detected, again I will start from S0 again, freshly. Getting? Freshly. So this is the key. So this is a state diagram. Melee 101 sequence without overlap. So now state table. What is the state table? State table means, so it will have present state, input, next state, output. Clear? Present state, input, next state, output. So now my present state is S0. When S0, I am giving, okay, input is 0. So then what is my next state? My next state, when I am giving input 0, I am staying same place, right? My next state also S0.
S0.
Output is 0. Now my present state is S0. If I am giving input 1, my next state is
S1.
S1. Output is 0. Now my present state is S1. Input is 0. S1. Input is 0. What is my next state? S2.
S2.
Output is 0. My present state is S2. Sorry, S1. Input is 1. So then my next state also S1. Output will be 0. My present state is S2. So S2. So input is 0. My next state is S0 and output is 0. If my present state is S2, input is 1, next state also S0 only, and output will be 1. When finally 101 is detected, right? Output will be 1. This is the thing. This is the second step of state diagram, state table. So after that, third step is we need to be make into the binary format. So now how we'll make into the binary format? Mean S0 is equal to 0 0, S1 is 0 1, S2 is 1 0, S3 is 1 1. So you need to substitute those values here simply. Clear? You need to substitute, okay? In place of S0, you need to substitute 0 0 value. In place of S1, you need to substitute 0 1 value. Getting? So this is the cases. So this is the Miller's state diagram without overlap. Okay, with overlap will be there, then more, without overlap, with overlap will be there. Okay, so how that implementation, how the state diagram implementation, we'll see in the next one, because this is less time we have, right? So we can't implement it now. Okay, so this is the process. Clear? Any questions, any doubts? So if you don't have any doubts, so then I'm stopping here.